of whatever. And this is my United States of whatever.
Alright, just finished building a little boost converter. Breadboarded it for a Nixie tube. That's a IN-8-2. I got it hooked up just with some alligator clips there on a perf board. The power supply boosts 12 volts. Let's see this here. 12 volts DC at a really small current. It's not on right now, but boost that current or boost that voltage up to 170 volts. Power comes in through, I got a little switch here. 12 volts comes in, powers a MC34063A switcher chip. And then there's a, the main heart of it is a 100 microhenry inductor, 1 microfarad of high voltage capacitance, and then some voltage feedback there. There's a nice high voltage MOSFET that's doing the switching, and it works quite well actually. Check this out. Comes right up, rock solid voltage regulation, and if you look on the scope over here, you can actually see the rise time. Every time I click the switch, you can see it redraw, but no overshoot. There's no overshoot due to really fast feedback path, no extra capacitance in the feedback path, and current limiting on the input current to the inductor. So let me zoom in here. You can see there's the 34063A switcher chip on semi, but right down there is a 0.2 ohm resistor that's in series with the power, so it limits the max peak current to the inductor, which is 100 microhenry. Here's the switch. It's a ST switch, capable of 600 volt breakdown, drain to source. I built a little basically a current amplifier there out of 4401 and 4403 BJT transistors. So the output of the switcher is basically, it's a Darlington transistor that switches 12 volts to these current amplifier here that then drives the gate of the MOSFET, and there's just a 510K or a 510 ohm pull down resistor on the base of those two transistors, and then there's a 10 ohm resistor in series with the output of the transistors to the gate of the MOSFET. The feedback path here, let's see, so current comes in through the 0.2 ohm resistor, through the 100 microhenry inductor, through a high voltage diode, and then that goes to our 2.47 microfarad capacitors for about a microfarad total. The output here, I just got a resistor kind of going to nowhere so I can clip on power to the Nixie tube, and then the voltage feedback path is through an adjustable 500K potentiometer, a smaller one that wasn't really doing the job at the low end, and then some other divider resistors here coming back to the chip. So in a nutshell, that's the circuit. I'll give you a nice close-up here of the Nixie tube. Pretty sweet. I just got the 6 lit up here, but it does do 0 through 9. The intent is to make a clock out of it. It's been done to death in different flavors, but it still is really cool. If my buddy and I can think of a different purpose for this tube other than a clock, a single-digit clock, or a full 4-digit clock, or even a 6-digit clock, then we'll come up with something. But right now the plan is to just make a single-digit clock, start small, and work our way up. So that's the Nixie tube. Got the power supply built, so we got to hook up the rest of the circuit. Thanks for watching.